Okay, guys. Now, right here, you're gonna work on reflection. All right. Now here in the graph, they already point letter S and 5, 3, which is right here. Now it says, in each column, write the coordinates of the points that are related to the given point by the criteria listed in the first column of the table. Point S, 5, 3, has been reflected over the X and Y axis for you as a guide, meaning like they already did it for you. And its images are shown on the coordinate plane. Use the coordinate grid to help you locate each point and its corresponding. Now I'm going to do the first one for you, which is S, 5, 3. It says here, the given point is reflected across the x-axis. First, I need to find the x-axis, which is this one right here. Now I need to put a reflection, meaning like, what would it look like on a mirror? So I'm going to pretend like the x-axis is the mirror, and I'm going to find it on the other side. So I'm going to flip it along the x-axis, and it's going to end up right here, which is letter M. And I'm going to come to my box and write the new point, which is 5, negative 3, parentheses, letter S. Next, the given point is reflected across the y-axis. I need to find the y-axis, which is this one right here. I need to pretend like that's the mirror, okay? And I'm going to flip it to the other side, which is going to go all the way over here. All right, I need to go the same distance, but on the opposite side. What is the opposite of positive 5? Negative 5. All right, so my new point for this one is negative 5, positive 3, because I still went up along the y-axis, and that point is letter L. Now here are the tricky ones. Right here, there's two reflections. It says the given point is reflected first across the x-axis and then the y-axis. So I'm going to look at letter S. First, I'm going to reflect it along the x-axis, and then I'm going to reflect it along the y-axis, and that takes me all the way to point A, which is negative 5, negative 3, and letter A. Negative 5, negative 3, and that is letter A. Now the last one, the given point again means like the point that they give you, which is 5, 3, reflected across the y-axis and then across the x-axis. So on this one, we need to reflect towards the y and then the x. So I'm going to start at S right here, move along the y-axis, and then I'm going to reflect along the x-axis. And that takes me to that same point from before, which is negative 5, negative 3. Point A. Now you're going to do the same thing for the given points, negative 2 and 4, positive 3, negative 2, negative 1, negative 5. So first you need to plot these points, and then you do all the reflections. And then you have to write the points in the given box. Alright, now on this page you have 4 friends touring on motorcycles. They come to an intersection of 2 roads. The roads they are on continue straight, and the other is perpendicular to it. The sign at the intersection shows the distances to several towns. Now what they're talking about is two lines that are intersecting. There's my y-axis, and there's my x-axis. It says here, draw a map diagram of the roads and use it and the information on the sign to answer the following questions. Now I'm going to first do Albertsville. Where do you think Albertsville is going to be? It says right here, 8 miles to the left. So I'm going to put right here, just pretend like that's 8. Next one is Blossville, which is 3, right here. Cheyenne, 12, way up here. Dewey Falls, 6 to the right. So pretend it's right there. Now, what is the distance between Albertsville and Dewey Falls? So you need to find the distance between here and here. Next question. What is the distance between Blossville and Cheyenne? What is the distance? You're going to start at 3 and count how many units go all the way to 12. Okay? Try to see if you can find a pattern to find both answers. Now, you don't need to do this problem. So move on to the next. Now on this page, what do the ordered pairs have in common? What do these ordered pairs have in common? What does that mean about their location on the coordinate plane? They want to know where are they on this coordinate plane? Are they in quadrant 1, 2, 3, 4? Or are they on the x-axis or y-axis? Now the next question is, how do we find the distance between the two numbers on the number line? First, you need to plot -4, 0, which will be probably like right here, and then 5, 0, which will probably be like around right there. What is the distance from here all the way to here? And then you have to use the same method to find the distance. Then you actually find the distance here. You explain in words right there. Consider the line segment with endpoints 0, -6 and 0, -11. What do the ordered pairs of the endpoints have in common? What does that mean about the line segment's location in the coordinate plane? Does that mean they're on the same x-axis, y-axis, the same coordinates? What is it? What do they have in common? Do they both have positive numbers? Do they both have negative numbers? Next, find the length of the line segment described by finding the distance between its endpoints 0, -6 and 0, -11. Now I know that all you have to, some of you guys might think, oh, I just need to do the absolute value of 6 and the absolute value of 11 and then add them together. That's not true. It works sometimes, but only if they're on different sides of the axis. If you notice, it says -6 and -11. How far is it from -6 all the way to -11? You have to count how many segments there are in between those two. Now, these two problems are the same as the other. They just want you to describe the location and what they have in common. Then you find the length of the line segment. Remember, line segment is a point, a line, and then a point. What's the distance between here and here? And then lastly, all you have to do is just find the length of the line segments whose endpoints are given below. You don't need to explain how you determine the line segments or horizontal or vertical. All you have to do is just tell me the length. Now, I'll do the first one for you. I notice that they both have -3 and -3. So I'm not going to work with those. I'm just going to work with the 4 and the 9. I'm just going to pretend that I draw an x-axis. And I know that it's a +4. So I'll pretend that this is a 4. And over here is a 9. Now, there's two ways I could do it. I can count 1, 2, 3, 4, 5, or I can just do 9 minus 4 equals 5. Now you're going to work on B, C, D, and E on your own.